Hello everybody. In this lesson, we are going to see the cleavage of covalent bond. In the previous lesson, I have explained how the covalent bond has been formed and how many types of covalent bond are there in organic compounds that we have learnt in the previous episode or previous lesson. In this lesson, we are going to understand the mechanism. You know that whenever we want to do any chemical reaction, old bond has to be broken and new bond has to be formed. How the new bond have been formed, how the cleavage of covalent bond, how the dissociation of the covalent bond takes place. Even though the covalent bond has been formed by the mutual sharing, when you cleave them, it may not be cleaved in a same manner. It can be cleaved in an indirect manner. It can be cleaved in a not symmetrical manner, unsymmetrical manner. How the cleavage has been taken place, whether it may be homolytic cleavage or heterolytic cleavage, and that cleavage may leads to anions, cations or free radical. Depending upon the cleavage, you are going to have the different steps, different paths in the mechanism. So that you are going to learn in detail in this particular chapter. Once you understand this chapter, once you go through this chapter, you will be able to understand different mechanism that has been there in a chemical reaction through the cleavage of covalent bond. You know that whenever an inorganic reaction takes place, it takes place between the ions, whereas organic reactions are molecular in nature. Therefore, they may involve a single molecule or it may take place between two molecules. Therefore, organic reactions are very slow reaction, whereas inorganic reactions are instantaneous because they're already half of the reaction is already over. The cleavage has been taken place. But when you consider the organic molecules or organic reaction, the covalent bond has to be broken and the new bond has to be formed. So the organic reaction which involves the transformation of one structure into another through the rearrangement of atom or a change in bonds. So this is the way the rearrangement has taken place. Old bond has to be broken and new bond has to be formed. The organic reactions are represented by chemical equations in which the formula of the reactive molecule and those products separated by an arrow mark. In the previous lesson, I have explained why the different types of arrow marks we are going to use. Here we are going to use the arrow mark which is pointing towards the product. This is a arrow which going to separate the reactants and the product. The conditions, catalyst, pressure, temperature are mentioned above or below the chemical reaction. Sometimes symbol like H nu or delta are used. And delta represents that it is a thermochemical reaction where heat is involved. Similarly, H nu, photochemical reaction, we are going to use the H nu. So sometimes we are going to write reactants are there, conditions we are going to write above the arrow mark or below the arrow mark, and arrow mark is always pointing towards the product and the product will be. This is the way we are going to represent the organic equation. So reactant and the product. The reactant may be same or it may be different. If A and A is reacting, then also they are going to combine together to form the product. If they are different, then it will become A plus B, that also going to give the product. One of the reactant is that the substrate and other one is we are going to call it as an attacking species. If both of them are neutral, if there is no polarity in the molecule, then the reaction doesn't take place. In order to take place, the reaction has to be takes place. Then the old bond has to be broken. So why it going to broken? Because one will be attacked by the other. One is attacking, that we are going to call it as an attacking agent, which is getting attacked, that we are going to call it as a substrate. Here when you consider the two reactants, it may be same or different. One will be a attacking reagent, other one we are going to call it as a substrate. That means attacking reagent plus substrate, they are going to get join together to give the product. So while giving the product, immediately I am not going to get a product, I am going to get in between. I told you the attacking reagent will going to attack the substrate, thereby your substrate will get converted into a intermediate. Their lifespan is very short, that's why they are called as reactive, and they are going to give the products. If it's a one-step reaction, it is called as concerted reaction. No matter how many bonds are broken, the starting material is directly converted into product. Whereas sometimes what happens, a stepwise reaction involves more than one step. A static material is first converted into an unstable intermediate called a reactive intermediate, which then get into a product. The step of the organic reaction depicting the breaking and making of new bonds of a carbon atom in a substrate, leading to the formation of the final product through transitionary intermediate. That entire path, entire way, we are going to call it as a mechanism. How the reactants are getting converted into product through intermediates, that we are going to call it as the mechanism. Account of each step, describing the details of the electron movement, energetics involved during the breaking and making form. Always the energy should be lesser, then only that reaction will be economically feasible, energetically feasible, otherwise the reaction doesn't take place. So all those details will going to be there when you consider reaction mechanism. A covalent bond joining the two atoms exists because of the shared pair of electron. When two atoms are separated from each other, the bond fission or cleavage takes place. Fission process can occur in two ways. I told you, you have a covalent bond. Always a covalent bond will be there in the organic molecules. When you cleave the covalent bond can be cleaved in two different manner depending upon the nature of the bond, depending upon the nature of the attacking reagent and conditions of the reaction. The separating atoms may take one electron each of the bonding pair, and one atom may take away with both the electrons. So when you consider the cleavage, the bond is cleaving, the cleavage is taking place, dissociation is taking place. But here the cleavage can take place in such a manner that whatever the bond electron, in order to form a bond you require two electrons. Both the electrons, if it is taken by any one of the atom, that may be one condition, one probability. The second probability is that one electron is given to A, other electron is given to B. So if that is the case, then we are going to call it as homotrically. Same way, in a similar manner, in a symmetrical manner, the cleavage is taking place. Such type of cleavage we are going to call it as a homolytic cleavage. Here there is a bond between A and B. A can, after the cleavage, A will take one electron, B will take electron. Both the electrons going to form a bond. When you cleave them, one atom will take one electron, another atom will take another electron. That type of cleavage we are going to call it as homolytic. Homo means same. In another case, what happens? The A is giving away both the electrons and B is taking away both the electrons. That type of cleavage we are going to call it as heterolytic cleavage. Homolytic cleavage leads to free radical, whereas the heterolytic cleavage leads to ions. The species which going to give away its electron, it going to carry the positive charge. The electrons taken away by the atom which going to take away both the electron, it going to take the negative charge. Always giving is a positive attitude, therefore after giving, A will going to take A plus. Grabbing is a bad attitude, it's a negative attitude, thereby we are going to write the negative charge on the B atom. So this is the way the cleavage takes place. It may be homolytic cleavage or it may be heterolytic cleavage. Homolytic cleavage, breaking the bond by equally dividing the electrons between the two atoms in a bond is called as homolysis or homolytic cleavage. Equally divide both the electrons. A will get one electron, B will get one electron. Each atom will get one electron. This type of cleavage we are going to call it as homolytic cleavage. If you want an example, when you consider the photochemical reaction H nu, the chlorine in presence of the photochemical reaction or ultraviolet radiation are using a thermolysis, it get cleaved into chlorine free radicals. The atoms which going to have only one electron, that radicals, those intermediates we are going to call it as free radicals. So here you are going to get a chlorine free radical, 2 moles of chlorine radicals you are going to get. The two molecular fragments produced as a result of homolytic cleavage carry an odd electron each and are called as free radicals. These are the intermediates we are going to get where the homolytic cleavage takes place. Free radicals are the species which are going to have odd electron in them. Such intermediates we are going to call it as free radicals. Molecules which are non-polar generally undergoes homolytic cleavage. If they are polar, then the homolytic cleavage doesn't take place. If it is non-polar, for example, homoatomic atoms like Cl2, there is no two poles, both of them going to have the same pole, negative neutral pole is there. Such molecules we are going to call it as a non-polar. Non-polar generally undergoes homolytic cleavage. Reaction which proceeds via the intermediate formation of the free radicals often takes place very rapidly, because free radicals are, the lifespan is very short, they are highly reactive in nature, that's why they are going to carry the odd electron, therefore immediately they get converted into stable form. Wherever the electrons are available in the same system, it immediately takes away the electron and it get rapidly, the reaction is getting taking place, and the reaction takes place very fast, instantaneous reactions. Homolytic fission is the most common mode of fission in the vapor phase. Whenever, because you know that the cleavage in the vapor phase leads easy to take away the electrons. Therefore, generally we are going to do the in the vapor phase. Homolytic reactions are usually initiated by light, heat and organic peroxides. Heterolysis, breaking a bond by unequally dividing the electrons between the two atoms in a bond, is called as heterolysis. Here unequal division takes place. Here A and B is there. A is giving away all its electron, B is taking away. Which is giving away, it going to carry the positive charge, which is taking away, it going to carry the negative charge. So, it may on either way depending upon the nature of A and B. If which one is more electronegative among them, it going to pull the electrons. A may more electropositive or B may more electropositive. If B is more electropositive, it going to pull away the electron, it will become B minus and A will become A plus. If A is more electronegative in nature, then it going to grab the electrons, it will become A minus and B will become the B plus. The two fragments produced as a result of heterolytic fission, we are going to call it as ions, which going to carry the positive charge, that we are going to call it as a cation, which going to carry the negative charge, that we are going to call it as an anion. The cation means after losing the electron, it is going to lose the electron. The electron deficient species, that we are going to call it as a cation. Electron rich species, we are going to call it as an anion. Generally, the polar molecules undergoes heterolytic cleavage. Polar, as the name indicates, it going to have two poles. One is a positive pole, other is a negative charge. Partially induction will be there as two poles. Such molecules generally they undergo heterolytic cleavage. Heterolytic fission most commonly takes place in solution, whereas homolytic takes place in vapor phase. The energy required to break the bond can be partly drawn from the energy of solvation of the ions produced. This reaction takes place more readily in polar solvent catalyzed in presence of ionic catalyst, acidic or basic. So this is the way you can come across the cleavage of the covalent bond, which is the first step of any chemical reaction, either homolytically or heterolytically. Thank you. All the best.